Good morning, students. Today we are discussing two important topics. First is exponential function, second logarithmic functions. Before discussing this topic, I will discuss some points. These two topics are important. First, these topics used in maths, not only maths but science also. Second things, this topic very important because board asking every year without any gap 4 marks questions, every year asking 4 marks questions. So this is a very important. Next, if exponential function is based in the exercise 5.4 and logarithmic function is based on exercise 5.5. Exercise 5.5 is very important exercise or example also. This exercise very important. Every example came in the board exam. Every example very important example. So now discuss about the exponential and logarithmic function. According to definition here, exponential function means those function having the base is only positive real numbers and exponent will be all real numbers. Means exponent will be positive, negative and 0 also, but base will be only positive real numbers. According to definition here, of exponential function of the form where b is the positive real number and which is argument x occur in the exponent, means variable number will be coming exponent. This is called the exponential functions. And logarithmic function inverse of the exponential function is called logarithmic function, or inverse of logarithmic function is called the exponential function also. But before discussing of this in this topic, first we will go in the base of the function. First we will discuss a polynomial function, then we will discuss the exponential function. Now this is the polynomial function. This is short form of the function. Next here, this is next I will discuss here exponential function is short form fn. Exponential function, then we will discuss you logarithmic function. Three function here: polynomial function, exponential function or logarithmic function. The logarithmic function I will discuss in last. First we will discuss in polynomial and exponential function. Now first we observe here y equal to x exponent 1, y equal x exponent 2, y equal x exponent 3. This will be, and y equal x exponent 4 also. In this way, this is the polynomial function. Suppose we are draw the graph of these points here first. Suppose we are using in these points, suppose x equal to 1, then y equal also 1, x equal 0, then y equal also 0, x equal is, suppose we are taking here 2, then y equals here 4, suppose x equal I am taking 3, then y is equal to 9. Suppose we are changing the value of the x, then value of the y is increased. Value of the y is increased. But one question came in the mind: any other function is possible, those are value of the y is increased more times compared than polynomial functions. Means any other function is possible, those are value of the y increase more times compared than polynomial function. The answer is yes. Which function of this, name of this function is exponential function. Now discuss about the exponential function. Value of the y b exponent x. According to definition, b will be the real number, positive real number, x will be all real number, positive, negative and 0 also. Here x is called the domain of the function, or y will be called here range of the function. The silent feature we are discussing last of the silent features. So x will be domain will be the exponential functions all real number, and this will range will be the function. There will be only positive, base will be here positive real number, then value of the function also positive real number. Now second, y equal tan exponent x. Tan is the positive real number, tan here positive real number, and x is the all real number. Suppose you can write here y equal e exponent x. Suppose you write here 2 exponent 4 equal to 16, 2 exponent 5 equal to 32, 2 exponent 3 equal 8. These are examples of the exponential function. But how much change? Suppose you are changing in the value of the domains, in the value of the x. So how much changing in the value of the y? Now suppose I am using this function here. Suppose x, value of the x equal to 0. So value of the x equal to 0, then y equal 1. Suppose value of the x equal to here putting 1, value of y equal to 10. Suppose your value of the putting here x equal to 2, then value of the y equal 100. Suppose your value of the changing here 3, then value of y equal to 1000. Comparing both the data here, when changing x equal to 1, y value of the y equal to 1, but in exponential function, when you changing value of the x in 1, the value of the y is equal to 10 times increase. That means in this data, value of the y is more increase compared than the polynomial function. In exponential function, value of the increase y is more times compared than the polynomial function. Suppose we are drawing the graph of this point and this point here. So now look here how to discussing here. This is the y equal to x. This is the polynomial y equal to where? Suppose x equal to 1, y equal to 1. This is the straight line of the 45-degree angles. Second, we are drawing this graph. This will be coming the parabolic form. This is the equation of the parabolic form. Then graph will also convert in the parabolic form in this way. This will be converted here parabolic form. This is the y equal to x square. Suppose this is also parabolic form, y equal to x cube. This is also parabolic form. Then we can, this is the y equal to x cube. Means when power will be x is increased, then graph will be steeper here. Means toward the graph will be more steeper toward the y-axis. Steeper here means graph will be slope of the graph is more here. And suppose you are drawing this point, this according to this point, then x equal to 0, then y equal to 1. Supposing this point, the graph will be come in this point, suppose 1. This way. So this name of this point is 0, 1. Where x equal to 0, then y equal to 1. This is graph of this y equal 10 base x. 10 base x. That means exponential graph is more steeper of the polynomial graph. When we are drawing the draw the graph of the exponential, this is the more steeper compared than the polynomial. That means value of the y is more increasing in the compared than polynomial function. Second things, value of the this is the domain part here. Suppose you are increasing the domain part here, so y will be coming always positive value here. Why? Suppose I am writing here 2 exponent 4. Here answer come in the 16. I am using this example. Suppose you are changing here 2 exponent 10. 2 exponent here, 2 exponent minus 1, minus 4 here. This will convert to exponent 4. That means 1 upon 8. 16 here. So this also come here positive value, not come is negative. Suppose we are using the 10 exponent minus 2, then 1 upon here 1 upon 10 exponent 2, this is 1 upon 100. This will come 0.01. This is come also positive. Suppose we are using here 2 exponent 0 here, 10 exponent 0, sorry, 10 exponent 0 here, then value has come 1. So suppose we are putting the value as negative, positive, negative, positive and 0 also. The value always come here positive form. This will not come in the negative. Means in exponential function, always value value of the y is always come in the positive form. Value of the y is always come in the positive form, not negative. That means this graph will be never touched in this line. This will be the more close on the x-axis, but not touching this graph. This will be not touching the x-axis because the value of the y is not 0. Value of the y is never 0 here. Then this will be not meet in the x-axis and not cross will be the x-axis. Means value of the y is always positive, but not cross or not meet in the x-axis. The second things, well, this is the domain part. X here domain. X here domain part here. This will be all real number. All real number. X is the all real number and value of the y is range. This is the only positive real number. Means I am checking this. Suppose I am putting the 0, answer come positive. Positive number, then positive, negative number, then positive, negative number, then positive. So suppose you are using the more, power is 100 times, then your power is the 5 times, 10 times is 1 upon, 10 power 5 is 1 upon 1, 2, 3, 4, 5. So this will become 0.0001. Means when you increase the negative power here, then this will come the nearest of the 0 but not 0. Value of the y, this will be nearest of the 0 but not 0. It means this value of the y is never come in the 0 here or not negative here. This is a silent feature of this exponential function. 2, 3 silent feature. First, x domain is all real number here. All x will be domain all real number, means negative, positive, 0. We are putting here negative. We are putting negative, positive. This is not matter. Value of the y always come in the positive real number. Second things, this will be not meet in the y-axis, not cross of the x, so not meet of the x-axis, not cross with the x-axis, because the value of the y always positive real number. So this next I will discuss with you logarithmic function. According to logarithmic function using the log. Suppose you are using the any function, log means logarithmic function. The logarithmic function is log b base y equal to x. This is the standard form. Log b base y. This base will be converted in the base, or y will be here right and exponent will be right in the. This is domain part is domain and range part here in this way. So now suppose I am writing this way, log 10 base y equal x. Suppose you are writing a log e base y equal to x. Suppose you are writing this log 2 base 16 equal to 2, 4. And this way we write log 2 base 32 equal 5. And you will write this log 2 base 8 equal to 3. So this is the form of the exponential and this is the form of the logarithmic function. Every function exponential convert the logarithmic function. What value of this exponential form you can convert it in the logarithmic function. Suppose you are draw the graph of these points. I am taking this way. suppose I am taking x equal to 1, then value of the x equal to y equal to 0. The exponential function, logarithmic function here, graph will draw here in this point here. Now look here in this way. This is a y equal log, this is the y equal log e base x. Second graph will draw here y equal log e base e, or next suppose you are drawing here log in this point log y equal log 2 base x. 2 base x here 10 base x, here not e base x, here 10 base x. Suppose you are here 10 base x, e base x, and here 2 base x. Your base here changing here 10 base, e base, and 2 base. The base will be decreased, the graph will be change the shape of. The more steeple of the when base will be decreased and graph will be more steep. This is the name of this point here always. This is the 1.0. So this point always come in the logarithmic function, or this point will come in the logarithmic function, or this point come in the exponential function. So this way we will discuss about the comparison study of the polynomial function, exponential function, and logarithmic functions. Just note down, then next point we'll discuss. Yes, student, next point I am taking here, base change. Why is changing the base? What requirements of changing of the base here? So now, before changing the base, I will discuss log is two types, natural log and common log. What is the natural log? What is the common log? Now discuss here. First things, natural log. Second here, common log. Natural log means log e base, or common log means log 10 base. This is the base is the e, then is called the natural log, and base is the 10 is the common log. Natural log is also known as ln x. Ln x, yeah, y, this is not matter. Suppose your y ln y, suppose x the ln x. The short form is the ln. Natural log represents the ln. L and small l and small n. First thing, why need of this changing of the base? Because this topic is the differentiability. A differentiability most identity is the base e base. Then we have required of the e base. Second thing, how you change it now. Suppose here log 10 base x, then we write here log e base x, then log e base 10. This identity. Here write 10 base x means here you can write here log a base b, suppose here, then you can write here log e base b upon log e base a. Suppose base any a b c, this will not, here I am writing 10 base. So suppose here a b c, this will not matter. Suppose 10 base x means you converting the e base, the log e base x upon log e base 10. This is the identity of the converting to base change. Because mostly identity in differentiation is the e base. Then suppose we have the identity here d over dx log x. How to differentiate here? Second things here, in NCERT book, natural log is represent only log. Here not write e, not writing here e here. Means this is the natural log. Means log x means log e base x. Both are same. Or suppose write here any base a, b, c, d, 10, 2. This is base 10. Or suppose you are not writing any base here, means this is the base e. So NCERT book represent the log e base in simple log x. You are not right. Don't confuse you here. This is the log 10 base or natural base. This is the natural log. Not if you are not writing any base here, means this is the natural log. So this is differentiate of the 1 upon x. But suppose you are right, d over dx log 2 base x, or suppose you are writing a 1 upon x, the answer is wrong. This is not, this identity not using the 2 base, this identity use only e base and natural log. So then we are changing in the identity of, converting in identity log natural base. So suppose you are 2 base x, then you are writing the 1 upon x here, but the answer will be wrong. This is not correct answer. Now, what is the correct answer here? Now look here. Suppose d over dx log 2 base x here, then you will change here log d over dx and log e base x, or here you write log e base 2. Or this is the constant value here, e base 2, or this is you can differentiate only numerator. Because denominator always comes in the constant value. Always, every questions. You should not see this question. If you converting this common log to natural log, the denominator always come in constant value. The constant, in constant value, differentiation not having the any value here. This is the same right here. And what differentiate of this? This is the 1 upon x. So you will write here x, and this constant value will write here same here. And this x log 2. The differentiate of d over dx log 2 base x. The actual answer is log 2 base x, this, not this answer. But this is the correct answer. This is the wrong answer. This is the wrong answer. The log bit, why we converting here this is because mostly identity of in NCERT in differentiation, mostly identity in natural log basis. So they are required of the converting of the base to make the easy of the differentiations. Second point here, some identities of here, some log identity here, mostly students confusing these identities and doing the mistake in the board exam. Don't you look carefully and don't mistake in this. First identity here, suppose log m plus log n. You can write here log mn. Here no, I am not writing any base here because this is the natural log. Every identity for natural log. What mistaking here? Most students doing this log m plus n, doing this log mn. But this is wrong. This identity right, this will be not equal. This form or this form we are changing because this is the separate log or this is the common log. Log will be never multiply the inside. In this type mistake student doing the in exercise, in this type question exercise 5.5 are mostly student doing in this type mistakes in exercise 5.5. So don't do mistake in this type. This identity, this is not identity, this is the mistakes only. Second identity here, log m minus log n. You can write here log m upon n. This is the correct identity. For what mistaking here? Same mistaking log m minus n. Student write here log m upon n. This is wrong. This is not correct. This is not correct. Correct identity is this is the wrong identity. Third, log m whole power n. You can write here log m n. This power will be converted in this multiplier. This n come in this form. Third, fourth, sometimes here, suppose you write log e base log x. You can directly write here x. E base log x square, then you can write directly x square. Suppose you have log x cube, then you write directly x cube. You have x square, x cube. So this is the important four important identities. don't mistake this. And if you require the change of the base, you do this. Don't use the natural base law, natural log questions convert into directly. Don't solve in the common law. First change the base, then you solve this question. Yes, so very important things, and note down.